Dear students and viewers, in the last session, we have discussed about this quadratic equation and how to find the slope of the quadratic equation. The general form of the quadratic equation is y equal to f of x equal to ax square plus bx plus c, which is called the standard form. There are also other forms called as a intercept form, and there are many methods to solve the quadratic equation, starting from graphical method, going by factorization, as well as we can use the intercept form to find the roots of this quadratic equation, and also we can derive the quadratic formula by which we can get the roots of this quadratic equation. There are many methods. Today in this lecture, we can see about the usage of the graphical method or the graphical form in finding the various roots of the quadratic equation, as well as we will try to figure out whether there will be some real roots will be there, or there will be some imaginary roots, or the roots will not be there. So all those things we will try to capture with the help of the graphical method. For this, today I have taken the three examples, three cases. The first one is x squared minus 8x plus 12 equals 0, followed by the next two. Yesterday we derived the slope of this particular quadratic equation is given by g of x equal to ax plus b. From this expression we came to know that slope is not a constant, it will keep on varying at each and every x location. Okay, that's fine. Now let us go to the graphical method. Here x squared minus 8x plus 12 equal to 0. Here in order to draw the graph, I will tell you the factorization method also, then only we can get the logic. Here, the last number, I have to take the last constant and I have to multiply in such a way, let us say it is 6 and 2. If I am going to multiply, I should get a plus 12. If I am going to add, I should get minus 8. I will repeat once again. I am going to take the last constant when a equal to 1. When a equal to what? 1. That is also very important. That is, here the a equal to 1. When a equal to 1, I will take the last constant. Here the last constant is what? 12. Now I want to go by the method of factorization to find the roots. So when I am going by this method, when I am multiplying these two digits, I should get plus 12. And when I am going to add, it should become this coefficient. This coefficient is nothing but what? B. B is the coefficient of x. B is the coefficient of x. So when I multiply, I am getting 6 into 2 is what? 12. Even 4 into 3 is what? 12. Okay. So when I am multiplying, or even 12 into 1 is also what? 12. But we want to choose the combination which will give, when I am going to multiply these two numbers, I should get plus 12. And when I am going to add, it should give minus 8. It should give minus 8. So out of these three combinations, all are giving me only 12. When I am going to multiply, all the three are giving me 12. But when I am going to add, it is become what? 6 plus 2 equal to what? 8. 4 plus 3 is what? 7. 12 plus 1 is what? 13. It's not satisfying the B. It's not satisfying the B. So the way is that at least here we are getting 8. Instead of minus 8, we are getting plus 8. But it should be minus 8. So the logic is these two things are ruled out then. These two things are what? Ruled out. So here I can put minus 6. Here I can put what? Minus 2. So let us take the roots are minus 6 and minus 2. The values are what? Minus 6 and minus 2. So when I am going to multiply these two things, what will happen? Minus 6 into minus 2 will become plus 12. When I am going to add them, minus 6 plus minus 2 will become what? Minus 8. So I am able to get it. So now this 8x can be written as what? Minus 6x minus 2x. Minus 6x minus 2x. Okay, you can see x squared minus 6x minus 2x. Now also you see, if I am going to add, I will get minus 8x. Minus 8x plus 12 is equal to 0. So this is the logic. The logic begins is that when I am going to multiply by two numbers, I should get the constant. And when I am going to sum, I am going to add them, I should get the value of b. I should get the value of b. So I got minus 6 and minus 2. So it is x squared minus 6x minus 2x. Once again also you can verify. When I am going to add these two things, I will get what? Minus 8x plus 12. Okay, what is the usage of this one? The next question may be for you. Why I have to do like this? From the first two terms, you take x as common. So it is x into x. So it becomes x squared minus 6. So x squared minus 6x. In these two terms, you take minus 2 as common. So it becomes what? X minus 6 is equal to 0. Why? Minus 2x plus 12. So what is the advantage of these two things? In these two terms, now which one we can take common? X minus 6s we can take as x minus 6 as the common. So the remaining thing is what? X minus 2 equal to 0. Equal to what? 0. Now ultimately what is our idea? Ultimately our idea is to find the roots. X equal to what? 6. How I got this one? X minus 2 equal to 0. So x equal to what? 2. X minus 6 equal to 0. So x equal to what? Plus 6. Here is plus 2. Atul, what is the meaning of plus 2 and plus 6? What do you mean by the roots of a quadratic equation?
The graph means x-axis.
Where the graph means the x-axis. One more point, that's also right. Where the graph means the x-axis also the roots. One more thing.
Where y equals 0.
Where y equal to 0. Very good. So, I want to have, this is nothing but what? I can write y equal to f of x equal to what? X squared minus 8x plus 12. My idea is to know for what value of x my y will be 0. That is nothing but roots. That is nothing but what? Roots. Since it's x square, there are two values for which this y can be 0. There are two values for which this y can be 0. So what are those two values? One is plus x, another is plus 6. Now I hope you are very clear with the meaning of roots. So the roots are nothing but the values of x. How many values? Two values. Why two values? Because quadratic equation. The power is 2. So there are two values of x which satisfy y will be equal to what? 0. How we know? Because we equated to 0. Because we try to equate this function to 0, which means we try to make y equal to 0. Based on that only we arrived at x equal to plus 2 and x equal to plus 6. Okay, fine. You got it now. Now, this is the method of factorization. This method what I explained you call as what? Method of factorization. Now we got the roots. But beyond the roots, I want to get some more information. Some more information. For that only, we are trying to go with graphical method. For that only, we are trying to go with the graphical method. So for this equation, I will take this is y equal to f of x. For this graphical method, the roots are x equal to plus 2, the roots are x equal to plus 6, which means when it is 2, what is the value of y? 0. When it is 6, what is the value of y? 0. This is the logic. This is 0. Okay, fine. Very good. So now let me draw the x and y axis. It is x, it is y. So let us have it is 0, it is 1, 2, 3, 4, 5, 6. So the roots are 2, 0. So 2, 0 means this point. And another root is what? 6, 0. So when x equal to 2, y is 0. When x equal to 6, y is also once again what? 0. So now their graph of the parabola should pass through 2 as well as what? 6. Then we already know that graph of a parabola is always symmetric. It is symmetric with respect to a particular axis. It is symmetric with respect to a particular axis. So there should be a common point where these both curves should come and meet. Where these both curves should come and meet. How to find the value of x? Just you take the average of these 2 points. Just you take the average of these points. So x will be equal to what? 2 plus 6 by 2, which is means what? 4. Which means this side of the graph will come and touch. This side of graph will also come and touch at a common point. That common point is obtained at x equal to what? 4. How to get it? By taking the average. By taking the average. So 6 plus 2 is 2 plus 6 is 8 by 2 is nothing but 4. Now you know the x. What is the value of y? How to get it? Put the value of x in this equation. So y equal to x squared minus 8x plus 12. So y equal to 4 squared minus 8 into 4 plus 12. So it's 16 minus 32 plus 12. So it is 28 minus 32, isn't it? So the value is what? Minus 4. So what are the coordinates now? 4 comma minus 4. 4 comma minus 4. So what about this value? This value is minus 1. Or I have to draw almost same. So this is minus 2. This is minus 3. This is what? Minus 4. So as the coordinate now? Minus 4, 4 comma minus 4. This is the point. Got it? So this point is called the vertex. This point is the vertex. Why it's called the vertex? Because both the lines come and join at that point. So if you want to draw the graph, okay, similarly, okay, so this point is called as my vertex. This vertex is nothing but what? 4 comma minus 4. And what is the value of A? What is the value of A? A equal to 1. Whether A is greater than 0 or less than 0. What do we mean by greater than 0? Open upwards. Well, in the last issue we say when A is greater than 1, it will be open upwards. So this graph goes to the infinite position. But we come to know this graph will intersect the x-axis at two location, which means from this graph we got to understand that this particular quadratic equation has two real roots. It need not to be positive, it can be even negative. The same thing can happen to the other side if the equation is different. But from this equation we come to know that this quadratic equation has two real roots because it is intersecting the x-axis at the two location, 2 and 6. I hope you got it. So from this, one more line we can draw. What is the line we can draw in this graph? Axis of symmetry, very good. You can draw the axis of symmetry which passes through this particular point. So what is the value of x here? Now you know this is the axis of symmetry. What is the value of x here? It is 4, very good. So the axis of symmetry passes through when x equal to 4. The axis of symmetry here is a line which is parallel to y-axis. But at what x location? But at what x location is what? Exactly at 4. How do I know? Because vertex is 4 comma minus 4. So it will exactly pass through the point. This point is nothing but what? 4. There is also a formula to find the axis of symmetry. There is also a formula to find the axis of symmetry. That formula I will tell you right now. X equal to minus b by 2a. X equal to what? Minus b by 2a. Now compare this equation with this equation. So what is the value of a now? A equal to the quotient of x squared, 1. What is the value of b? B is nothing but what? Sorry, here, minus 8. So now you try to calculate x equal to what? Minus of minus 8 by 2 into 1. So it is 8 by 2, which is nothing but what? Plus 4. So now your axis of symmetry is nothing but a line parallel to axis which passes through 4. So now without even doing this formula, we are able to draw the axis of symmetry with the help of what? Graphical method or the graphical form. So the graphical form helps us to find out how many real roots will be there, whether it be 1 or 2. It can't be more than 2. It can be either 1 or 2 or even no real roots, that we will see now. Then we are also able to plot the axis of symmetry without knowing the formula also. Without knowing the formula also we are able to find. So the axis of symmetry is nothing but a line which is parallel to y-axis, but at what location? Are you clear with this one? Shall we move to the next one? Yeah, fine. Okay. So the first equation is over. Let us pass on to the next equation. The next equation is x squared minus 4x plus 4 equal to 0. Here also the quotient of x squared is 1. So there's no need to worry. We will go by a factorization method. The value is 4. The value is 4. So when I'm going to multiply, it should become 4. When I'm going to add, it should be minus 4. When I'm going to multiply, it should be what? When I'm going to multiply, it should be what? This constant. When I'm going to add, this should be equal to this b. Okay, so yeah, so addition should be this one, multiplication should be this one. So what is the answer? Very good. It is minus 2 into minus 2. Why minus 2 into minus 2? Minus 2 into minus 2 will give plus 4. When I'm going to add minus 2 and minus 2, what is the answer? Minus 4. So when I'm multiplying, I'm getting plus 4. When I'm adding, I'm getting minus 4. So the problem is solved. So how to write, what is the usage of this one? I can replace this term b, x squared minus 2x plus 4 equal to 0. Isn't it? Now also you add it, you will get minus 4x. Okay. So from these two terms, we can take x as common term. So x into x minus 2. I hope you will get it. I don't want to bore you. So minus 2 into what? X minus 2. Because minus 2 into minus 2 is plus 4. Okay, now out of these two terms, which one we can take? This x minus 2 is common. So what is left out? X minus 2 equal to 0. Which means when I'm going to equate this term, x minus 2 equal to 0, I will get x equal to what? Plus 2. When I'm going to equate this term to 0, I will get what? X equal to plus 2. So now there are two real roots but at the same location. but at the same location. There are two real roots. Earlier we saw at 2 and 6. Now we are also getting two roots, but at the same location. So what should be the point in the graph? 2 comma y axis 0, 2 comma 0. So that is fine. The point will be 2 comma 0. I'll come. So you know now there are 2 points which are 2 comma 0 and 2 comma 0. So it is 0, it is 1, it is 2. So the first point is also here. The second point is also here. What does it indicates? It should be the vertex. Very good. It should be the vertex because both the points are in the same location, means it should be definitely a common point between both sides of the curve. Very good. So the curve will be like this. The curve will be like this. This side is also coming and meeting at what? 2 comma 0. This side part of the parabola is also coming and meeting at what? 2 comma 0. So fortunately we can see this point becomes a vertex. This point becomes the, because there's only one point which is touching the x-axis. Here we have 2 points. So we try to find the midpoint and try to find the axis of symmetry. Now where will be the axis of symmetry? Along this 2 comma 0, a vertical line parallel to the y-axis. What is the formula for finding the axis of symmetry? X equal to minus b by 2a. I'll derive it later. So x will be equal to, what is b? B is minus 4. So minus of minus 4. Minus of minus 4. By 2 into a is what? 1. So 4 by 2 is what? 2. So at x only the axis of symmetry should come. So from the graph itself we are able to now tell there can exist only one repeated two roots. One repeated two real roots. One repeated two real roots. It is not like the case what we discussed last time. There will be two real roots at two different locations. But now they are the same location. So there are two roots which are at the same location. So that is the information what we can gain from this particular equation. And the corresponding graph is this one. And the corresponding graph is this one. Okay, fine. Now, Atul, I will ask one more question. What is the slope at the vertex? What is slope at the vertex? Yeah, now the vertex is a line tangent to this curve at this point. So the curve will become like this. So the slope will be 0. But how to tell through formula? Slope equal to g of x equal to what? 2ax plus b. What is x at this location? 2. X is what? 2. What is a? 1. What is b? Minus 4. What is b? Minus 4. So it is what? 4 minus 4 equal to what? 0. Okay. Now x squared plus 1 is equal to 0, which means x squared equal to minus 1. Then x equal to what? Plus or minus root of minus 1. Root of minus 1 is I. I is something but what? Imaginary part. It's a complex number, which means there is no real root. Which means there is no real root. So this graph, this equation says there is no real roots. It may be a complex number. It may have imaginary root, but doesn't have a real root. Okay. Now how to establish this fact through the graph? How to establish this fact through the graph? It is 0, it is 1, it is 2, it is 3. It is 1, 2, 3. Now, let us try to make use of the axis of symmetry. Let us try to explore the concept of axis of symmetry. What is the formula? Minus b by 2a. What is b in this equation? 0. Why? Because there is no term corresponding to x. Plus 0 into x plus 1 equal to 0. I can write in the standard format. And I can compare the value of d. It is what? 0. So what is the axis of symmetry? 0. What is the axis of symmetry? It's a line parallel to y-axis. But at location of x equal to what? 0. Which means it's along the y-axis. Along the y-axis. So my graph of parabola will be symmetry about the y-axis. This is the x-axis. This is what? Y-axis. Now my x equal to what? 0. Which means my axis of symmetry, that line also coincides with the y-axis. With the y-axis. Now I know the vertex will come along the axis of symmetry. I know at any case, the vertex will come along the axis of symmetry. In the second problem also we saw, this is the axis of symmetry, isn't it? The vertex will come along the axis of symmetry. In the first problem also we saw, this is the axis of symmetry, isn't it? So this point also comes under the what? Axis of symmetry. This vertex will also come along what? Axis of symmetry. But at the point where the two curves meet each other. So the one more logic what I want to communicate to you is that the vertex will always lie on the axis of symmetry. It can be either above or it can be exactly on the x-axis or it can be below also. Okay, fine. Now we know that the axis of symmetry will come along this y-axis line only. But where? Where? So here I want to find the value of y. Y equal to what? X squared plus 1, isn't it? Now what is the value of x? Along this axis of symmetry? 0. So it's 0 plus 1. So what is the value of y? 1. So what is the vertex coordinate? What is the coordinate of vertex? 0, 1. Because I know this is the blue color line is the axis of vertex. I also know the vertex should come along this line only. But how? When x equal to 0 in this equation, my y will be equal to 1. So this is the point. What this point is called as 0, 1. So the vertex is here, which means my graph, this is a common point to both the sides of the curve. So the graph will go like this. This side also the graph will come like this. Isn't it? Now the beauty is whether this curve is touching the x-axis? Not at all. Where x is not equal to 0, which means it doesn't have real roots. It doesn't have real roots. It may have imaginary roots that we can't tell with the graph. But here we can tell it doesn't have any real roots. But when I'm going by the method of factorization, I can find it becomes a complex number. It becomes a complex number. So from the graph itself, we can tell whether there will be two different real roots or same roots at the same location or the same number repeated roots, or there are no real roots. With the graph, we can able to tell. Now, in all these three graphs, one graph is like this, another graph what I have drawn is like this, isn't it? Somewhat like this. The another graph what I have drawn is, here there is one repeated two roots. Here there are two distinct roots. Here there is no roots. In all these graphs, what does the vertex indicates? In all these three graphs, this graph has a vertex here. This graph has a vertex here. This graph has a vertex here. Not even vertex. Not even, I will not tell vertex. The point at which both the curves meets. There is nothing but vertex. Now this graph, all the graph is open upwards or downwards? Upwards. So now what about vertex? Now what about A is value? I will give another clue. What is the value of A? Where is greater than 0? So what is the value of vertex? It varies, I agree. Vertex definitely varies. Here vertex is 1, 0, here it is 2, 0, here it is 4, minus 4. I agree. But the thing what I am asking means, here when I tell the answer, you got what I want to mean. Here all the vertex indicates the minimum value. Because A is greater than 1 means what? Greater than 0 means what? We'll get the minimum values. Because the curve is open upwards. I want to just recall the concept what we discussed in the last section. There we told when A is greater than 1, greater than 0, when A is positive, it will have a curve open upwards. And the vertex will give me the minimum value. Because after this point always is maximum, up to infinite. Here also it is what? Infinite. Here also what? Infinite. So with the graph, that part I just want to tell. Similarly, Atullah, I will ask you a question. If A is going to be negative, let us say it is A equal to minus 1, what will be the graph? There will be open upwards, downwards. There also three cases may be there. What are three cases? Two real roots, very good. Two same real roots, very good. No real roots. Instead of telling one imaginary root, we can tell what? No real roots. So just I will draw the graph and we will wind up the session. Okay. So we can see when, let us take a function like this. Y equal to f of x equal to the same function only, but A is less than 0. So let us take A equal to what? minus 1. So in this case, if I want to draw a graph, the graph will be open downwards. Open instead of upwards, it will be what? Open downwards. So there's a possibility of this graph. Now what are the roots at this point and this point? There are two real roots. And as you told, there's another graph. There's also another possibility of a graph where there is only one root but repeating twice. But there's also another graph which can be like this. This has no real roots. No real roots. One repeated real roots, two times, two different real roots. So this is the condition when A is what? Less than 0. So I hope now this graphical method is able to give more insight into the quadratic equation. I hope you enjoyed it. Thank you.